Yeah, now that we covered the motivations behind CNNs, we are now well motivated to talk about CNNs and their inceptions. Actually, CNNs have been around for many decades, but they became really popular with AlexNet and ImageNet about 10 years ago. So AlexNet is a particular CNN architecture and ImageNet is an image classification dataset. So CNNs and deep learning became really popular in 2012 when AlexNet, a convolutional network, won the so-called ImageNet competition, which was a very challenging image classification challenge. While AlexNet was not the first CNN, this was interesting for several reasons. So one of the reasons was that AlexNet achieved a 15.4% error on a top 5 prediction task. The second best method was not even close. The second best method had a 26.2% error. So you can see AlexNet was almost twice as good as the second best method, which was a traditional computer vision method. So let me briefly illustrate what top 5 prediction means. So on the right hand side you can see an excerpt of the ImageNet dataset. So here we have 8 images corresponding to different objects or animals. And below each image you can see the true class label. In the upper left, for example, there is an image of a mite. And the network, assume let's say you have 1000 classes, has 1000 output nodes. So here what we do is we extract the 5 output nodes, the class membership probabilities that have the highest values. And the 5 highest class membership probabilities are listed below the true class label here in this image. And then we check whether the true class label is contained among these top 5 predictions. If the true class label is contained in these top 5 predictions, we say that the network makes a correct prediction. Yeah, and this top 5 prediction task is in contrast to the top 1 prediction task, which we usually work with. So when we classified these handwritten digits before, we had a top 1 prediction task where we were only looking at the highest class membership probability to see if the corresponding class, the predicted class, matches the true class. So one reason why people were impressed with AlexNet is that it had this low error rate compared to other approaches. So the other reason why people were impressed was that AlexNet used GPUs to train it efficiently on large datasets. So many people in fact refer to AlexNet as the birth of modern deep learning because it had both a low error rate and it utilized GPUs in a modern way to train on large datasets. So AlexNet was created a long time ago, more than 10 years ago. Since then we have seen many popular architectures that are actually much better than AlexNet. So here's an overview of some of these architectures. So for example, some popular families of architectures are the ResNet architecture, the VGG architecture, or Inception networks. So this plot shows some of these architectures, their predictive performance on the y-axis, and the operational throughput, the computational efficiency, on the x-axis. And the diameter here shows the size in terms of the number of parameters of each architecture. So what we can see here on the y-axis, the higher we go, the more accurate these networks become. We can also see that some of these architectures are actually becoming bigger than AlexNet. However, another interesting thing you can see here is that the architectures above AlexNet are actually more accurate, but way smaller than AlexNet. So that means that larger is not always better. Now, as I mentioned earlier, in practice, we actually don't design our architectures from scratch because it's very laborious and it takes a lot of time to design an architecture that works well. So in practice, we actually commonly adopt these popular architectures. And in the next video, I will give you a whirlwind tour highlighting the notable concepts in these architectures. And we will adopt also some of these architectures ourselves and train them on our own datasets.